Hello, my name is Clemens Preisinger, and I would like to show to you a new feature which comes with Karamba3D version 2.2, namely beam loads. For this, to demonstrate beam loads, I set up this very small structure which consists of one beam which has fixed end conditions. You can see the setup here. The loads used to be all in the so-called loads component, which is a multi-component where it's possible to select the type of load from this drop-down menu. The component is still there. However, it's now the loads which work on both shells and beams, which can be derived from here. All the loads which only work for beams are now in the beam loads component. And this list of types is now available. I would like to start with a concentrated load. As before, it's possible to set here the beam or the identifier of the beam where the load should act. What's new is that you can use the element directly here in the loads component. You can select or set a load case name, and via the force and input and moment input plug, it's possible to set here force vector in kilonewton or a moment vector in kilonewton meter. The input T specifies the position of the load. T equal to 0 corresponds to the starting point of the beam. T equal to 1 corresponds to the end point. There are two types of load orientation. First one is local to element. This means that if I rotate now the axis of the system a little bit, that the orientation of load stays perpendicular to the beam axis. And the other option is a global orientation, which you can see here. Then the next type is the distributed block load. It's the replacement of what used to be the uniform line load, and by default it covers the whole beam, as you can see here. Again, it's possible to specify here a force and moment vector. This time, however, in kilonewton per meter and kilonewton meter per meter. The values T1 or T0 and T1 can be used to specify the starting point and end point of the block load. There are now three options for orienting the load. The first one is corresponding to the local element coordinate system, which could be, for example, wind pressure. Then next option is global, like additional dead weight. And the third option is global projected, which acts like snow. The next type of load is a so-called trapezoid load. Here again, one can supply a force or a moment vector, and the four T values here specify now the start point, the midpoints and the endpoint of this trapezoid load. Again, we have here the three orientation options as before. And the last type of distributed load is a polylinear load, where it's possible to define the load distribution via a direction, a list of force or moment values, and a corresponding set of t values, as you can see here. And there can be any number of values in these lists. Then the last type that's available are so-called gap loads, where it's possible to specify a displacement or a rotation discontinuity on the beam, displacement discontinuity or a rotation discontinuity, which can be used, for example, to calculate influence lines for cross-section forces at a specific position. And again, the orientation of these gap loads can be either local to element or global. That's it. Thank you for your attention. Goodbye.